Hello. So what we're going to do now is find the angle between two vectors when they're written as linear combinations. The last video we looked at where they were in component forms, but really it's the same thing. So we can turn a vector that's written in linear combination. So remember linear combinations like this. All right, so let's say we have a vector u, and it's written as a linear combination of 3i minus 4j. We can always write this back into the component form of 3 and negative 4. So we can go back and forth between the two. So remember the I is the x component and the j is the y component. So if you're graphing this vector, well, actually I'm going to need the whole axis here since it's negative 4j. I would go over 3, and this is the I direction, and I need to go down in the negative j direction to graph this. So let's use a different color. So it'll be over 3 and down 4, 1, 2. So that is what vector u will look like graphically. So we can just go back and forth here. So let's look at an example when we're given the notation of a linear combination, and let's figure out how to solve it. So what I always do when I solve these is just change it back to the component form to make our lives a little easier. Okay, so u is given as the component form of 2i, and I'm just going to put a hat over the I just so we know it's a vector and not the imaginary number I. I'm going to put a hat over that j. All right, so v is given to us as negative 5i plus 2j. So I'm going to just change this over to component form now. 2 and 6. And that will be negative 5 and 2. All right. So we're just going to find the angle between those two vectors there. So we're looking for that angle in between the vectors u and v. That's the problem we're working on. Okay. So it's the same formula we used before. So it's cosine theta is equal to the dot product over the magnitude of each individual vector multiplied by each other. So we'll just write them in component form. All right, so it's 2, 6 and negative 5, 2. 2, 6 and negative 5, 2. So remember the magnitude is the first term squared plus the second term squared of each vector. So it's going to be negative 5 negative 5 squared and 2 squared. And let's just simplify that up a little bit. I'll get used to this pen eventually, but as you can see, it's a work in progress. So the top is going to be 2 times -5 is -10, plus 6 times 2, which is 12. The bottom is going to be the square root of 2 squared is 4, 6 squared is 36, so square root of 40. And the other square root is going to simplify to -5 squared, which is 25. And 2 squared, which is 4. So let's write that on the other side. The top's going to be +2. So we're going to have the cosine of theta of +2 square root of 40 and square root of 29. And square root of 29. So we just need to do the cosine inverse of both sides and see what we get. So do that to that side and to that side. Now just remember that your calculator is in degrees so we can get the correct answer. All right, so let's punch that in the calculator real quick. And make sure we use parentheses. More parentheses, the better, to make sure we have the correct equation. Okay, so we'll do cosine inverse, parentheses 2 divided by, let's do parentheses again, square root of 40 and square root of 29. And when we do that, we will get 86.63. If we go to the hundredths place and make sure we put degrees there. Okay, so that's how we do a problem whenever we're given initially the linear combination of the vector and we just transform it to the component form.